All right, we're picking up at number 20. It says, in a triangle, the measure of the second angle is 6 times the first. And the measure of the third angle is 20 more than 3 times the first. So what we want to do is definitely draw a triangle. And again, the key with translating a sentence like this from words to algebra is to realize at the end of the sentence is your x. So if I call this triangle ABC, I'll let A be the first angle, and that's going to be x. Then it says in the triangle, the measure of the second angle is 6 times the first. So let's let B be the second angle, only because it's the second letter of the alphabet. And so 6x would be angle B. And notice, again, these are angles, so we're putting the measurements in the mouths of the angles. And then it says the measure of the third angle is 20 more than 3 times the first. So the first angle is x, so this would be 3 times the first plus 20. Now, it says this triangle is classified as, and these are the choices, we don't really have any information to help us out with this. We actually have to solve a problem here, and we have all 3 angles of the triangle. So we can take those angles and add them all up to 180 degrees. So we have x plus 6x plus 3x plus 20 equals 180. So x plus 6x plus 3x is 10x. Subtract 20 on both sides. And so we get 10x equals 160 divided by 10. X is 16. X being 16 will help us figure out what the angles are. So the first angle is x, so that's just 16. 6 times 16 is 96, so angle B is really 96. And 3 times 16 plus 20 is 68. So here are the 3 angles of the triangle. As you notice, 16 is acute, so this is acute, 68 is acute, and 96 is obtuse. So that makes this an obtuse triangle. Just to understand the rest of the choices, it's not a right triangle because there's no right angle. It's not isosceles because none of the angles are equal. And it's not acute because of the obtuse angle. All right, number 21 says, in the diagram below, find the measure of these 3 angles. What I do is, with this type of question, is just to kind of ignore what you're being asked to find first, and just go with something that's very easy. So right here we have a 154-degree angle at ABF. So if you're not sure what I'm talking about, you're going to see in a second. And it forms a linear pair with FBC. So to find angle FBC, we can do 180 minus 154, which is 26. So now we have this angle, 26. And now notice, FBC is a triangle. So we have 2 angles in that triangle, and so we can always find the third. So 16 plus 26 is 42. And a lot of you just put the 42 here, but that doesn't work. You always have to remember to subtract 42 from 180 degrees, which is the sum of all the angles in the triangle, and we end up with 138. So angle BCF is 138. And now again, I could take the 138 and kind of go like this. And we have 2 supplementary angles there. So to get angle FCD, we can do 180 minus 138, which is 42. Which, by the way, isn't surprising because this is an exterior angle of triangle FBC, and 26 plus 16 is 42. And we knew that. That's the exterior angle theorem. All right. Now we have a triangle with 2 missing angles, but luckily we were given 158 over here. So we can get the missing angle CDF. So that's 180 minus 158, which is 22. So now I have 2 angles in the triangle. We want to find the third. So we need to take the 22 and 42, adds up to 64, and subtract from 180, which is 116. So angle CFD is 116. So now we have to answer the questions. Angle FBC, F to B to C is 26 degrees. Angle FCD, F to C to D is 42 degrees. And here's the tricky one, B, or just a little harder, angle BFD is the wide mouth. So we need to add up these two pieces. 16 plus 116 is 132. And there would our answers be. Next up, next page, number 22, it says if the ratio of the two corresponding sides of similar triangles is 3 to 8, what is the ratio of the perimeters? And the ratio, you have to know that the ratio of the sides and perimeters are identical. So this is also 3 to 8. Next question says if the ratio of the two corresponding sides are 3 to 8, what is the ratio of the areas? To go from the sides ratio to the area ratio, you square the numbers. So 3 squared is 9, and 8 squared is 64. Number 24 says if the ratio of the areas of two similar triangles is 16 to 49, what is the ratio of the corresponding sides? So from sides to areas, we squared the numbers. So if I want to go backwards, we take the square root. So the square root of 16 to the square root of 49 is going to be the answer. The square root of 16 is 4, and the square root of 49 is 7. So here's your final answer, 4 to 7. All right, in triangle ABC, it says D is the midpoint of AB, and E is the midpoint of AC. So these guys are midpoints, which makes a midpoint equilateral triangle, which in class, as we discussed, is actually half the size of the big triangle. If you notice, if I went down here, that red part is highlighting about half the line. Okay, and it works for all the segments. So it says if AD is 6, find the length of DB. DB, since AD is a midpoint, these guys are equal, and so DB is also 6. Then it says if AE is 5, so I'm going to erase the old stuff. I don't know that it's true anymore. AE is 5. They would like us to find AC. Well, AC is, since E is a midpoint, AE and EC are equal, so this is 5 also, and so AC is 5 plus 5, which is 10. And here's the nice part. Same relationship exists. So if DE is 7, notice DE corresponds with BC. So if DE is 7, that's coming from the small midpoint triangle. What we do is, just like 5 times 2 is 10, do 7 times 2, and you'll get the corresponding side BC, which is 14. Number 26. Last but not least, and again, please ignore the copier line. In triangle ABC, it says DE is parallel to BC. So right off the bat, we get similar triangles. If AD is x plus 2, DB is 5, DE is x, and BC is 12, they would like us to find the length of AB. Now here's the deal. This 5 is the tricky part. That 5 is not a side. It's not a full side in one of the triangles. So what we do is to form the full side in the large triangles, we add these guys up. Now, I've seen some kids have trouble with this. It's just combining like terms. It's 5 plus x plus 2. 5 plus 2 are numbers. They're like terms, so that's 7. And I have the x. So this full side would be x plus 7. Now, there are many ways to do your ratios, but I'm going to go like this. I'm going to take the small triangle first. Okay? And I'm going to do left over bottom. Okay? So I'm doing left over bottom, so I'm going to put that here. In the small triangle, I'm going to do left over bottom, so I'm doing x plus 2 over x equals. I have to do the same exact setup in the large triangle. I have to do left over bottom. Left is the x plus 7 that we just added up. And bottom would be 12. Notice the 5 does not enter into this at all. Once we've added the 5 to the x plus 2, it's the x plus 7 that's being used, not the 5. All right, next up we have to distribute. This gets a little tricky. 12 times x plus 2. So 12 times x is 12x. And 12 times 2 is 24. Equals algebra. X times x plus 7. X times x is x squared. x times 7 is 7x. So here's our algebra set up. And again, we see x squared, which is a celebrity. So we have to move everybody over to that side. So the 12x and the 24 have to move to the right side of the equation. So minus 12x minus 24. And notice I'm going to put the negative 12x underneath the 7x because they're like terms. And I'll put the negative 24 to the side because right now there's nobody like to him on the right side of the equation. These cancel and become 0. And this equals x squared minus 5x minus 24. And so now, last year, you did a lot of this. We have to know how to factor. And I am factoring x and x. And I'm going to do it the way I showed you guys in class if you have trouble. This sign needs to come down. A negative times a what gives you a negative? Well, this would be a positive. And now we have to think of numbers that multiply to 24 that when I fill them in the blanks are going to add up to negative 5. And the answer to that question would be negative 8 and positive 3. All right? So now each factor can be set equal to 0. Add 8 to both sides, and x is 8. Subtract 3 from both sides, and x is negative 3. We're rejecting the negative x value because we're in geometry. You can't have a negative length. So x is 8. And we have to go back to the question and make sure we understand what it's asking. It's asking us to find the length of AB. AB is from here to here, which is not represented by x. It's represented by x plus 7. So again, getting that x value is a part of the problem, but not you got to finish it off. So we want to get AB, which is actually x plus 7, which is 8 plus 7 equals 15. Alternatively, you could do the pieces. So you know BD is 5, and AD is x plus 2. So x was 8. 8 plus 2 is 10. Plus 5 will also give you the 15. And that's just as good as the way I did it. And that's it. So now you have all the problems, and you've seen everything, and you should be ready for your test.